Factoring a quadratic is a strategy we use to be able to convert from a general form to a factored form of a quadratic. Just to review, factors, remember, are like this. So if I have a number like 6, the factors of 6 are 2 and 3 and 1 and 6. Remember, 6 being the product, and then 2 and 3 and 1 and 6 would be the two numbers that multiply together to get 6. Today we're going to look at a different type of product. So instead of a single number like 6, we're going to be looking at a quadratic, which looks like general form, 2x squared minus 5x plus 3. And we're going to turn it into factored form, or a set of two quantities that multiply together to get this. Now, when we did factored form to general form, we were multiplying 4 times. So if you use the area model, FOIL, or the traditional algorithm, you were always multiplying 4 times, getting an answer that looked like this: ax squared plus bx plus c. Something that at the very end you would have to convert your two bx terms. When I say convert, I mean combine those together to be able to get a trinomial at the end. So today we're going to use a diamond problem, which we have been practicing, and the numbers a, b, and c to help support our work. So let's go ahead and get started. So in order to solve or to factor this quadratic, what we're going to be doing is taking the ax squared term and the c term, and we're going to be multiplying them together. So when I multiply 2x squared times 3, I would get 6x squared. So in a diamond problem, we usually contain our product in the very top of that diamond. So that's what we're going to be doing. And then we're going to take a look at this middle term, which is negative 5x, and we're going to put it down here in the sum. Now, what we're going to do is we're going to look for two factors, two of them, that multiply together to get 6, but add together to get negative 5. Now, in my mind, I know that if I have a product that's positive and a sum that's negative, I need to have two numbers that are negative to be able to fulfill this criteria. So I'm going to go ahead and look at my list of factors of 6. The only way I can get a product that's positive is to have two positive numbers multiplied together or two negatives. And because my sum is negative, I know all of these factors have to be negative. So the only one that would fit this criteria would be this set of factors, negative 2 and negative 3. So I'm going to go ahead and place them right inside here. Negative 2x and negative 3x. Just, in a diamond problem, it doesn't matter which number you put in first, but these would be considered like our bx terms. So as I look at this example, we're going to go ahead and start to set up how we're going to actually show those 4 multiplication parts to be able to get us into that factored form. And we're going to use the area model. So I'm going to go ahead and set a 2 by 2 square or rectangle up. So when I say 2 by 2, if I'm multiplying two numbers by two numbers or variables, we call those binomials. We're going to go ahead and set a 2 by 2 rectangle up. Okay? So if you were using the area model before, typically our ax squared goes in this lower left-hand corner. So I'm going to write 2x squared. And then our c term goes up here in this upper right-hand corner. Now, what I need to do is I need to think of, just like what we did here, two numbers that I could place in here, or two, and obviously they're going to have the variable x, but two terms that I can put in here that not only multiply together to get 6x squared, but also add together to get negative 5x. And that's where I'm going to pull this negative 2, and I'm going to put it right inside one of those boxes, and then I'm going to take that negative 3x and put it over here. Okay? Now, I don't know if you remember the word or the phrase GCF, but what we're going to be doing is looking for the greatest common factor of each column and each row in this rectangle. Okay, so let's go ahead and start off with this first row. So if I look across here, I see negative 3x and 3. The only common factor that they have is 3. So what I'm going to do is put the 3 out front. Okay, so the greatest common factor of 3 and 3 is 3. We're going to worry about the signs in just a moment. Okay, now let's go ahead and take a look at this row right here. I see 2x squared and negative 2x. I see that they both have 2 in common, or that's the greatest common factor of both of the numbers. And do you notice how they both have a factor of x? Just remember, x squared means the same as x times x, and they both have a variable x. I'm going to erase that just real quick. So I'm going to pull out that x here. Now there's two ways to fill this out. You can use the process of elimination to find out the other factor down below by figuring out what do you take times 2x to get 2x squared. Okay, I'd have to put an x down here. So again, 2x times x is 2x squared. Now, let's go ahead and take a look at this. If I have an x here and a 3, I wouldn't get negative 3x. So I'd have to put a negative here. Negative 3 times x is negative 3x. Then I'm going to go ahead and look at this one. So 2x times something equals a negative 2x. The only thing I can think of is negative 1. So let's go ahead and verify a couple things. Is the greatest common factor of 3 and negative 2 negative 1? Well, the greatest common factor of 3 and 2 is 1, but we had to modify that based on the sign. And then just right here, the greatest common factor of 2 and 3 is 1. Remember that 1 is invisible. And then they both have a common factor of x. So at the very end, when I go to write my factors, what my factored form would be is this. It would be 2x minus 3, and my other factor here would be x minus 1. Now sometimes we think we do a really nice job of factoring, but it's always important, regardless of how we feel about the process, to go back and check our answers. If you use the area model, you're more than welcome to remodel here. If you use FOIL or another strategy, all I want you to do is go ahead and remultiply. So I'm going to go ahead and use FOIL to help me today. So 2x times x is 2x squared. I'm going to do 2x times negative 1, which is negative 2x. I'm going to put that right here. Negative 3 times x is negative 3x. And then I'm going to do negative 3 times negative 1, which is 3. I'm going to write this in. And then, sure enough, negative 2x and negative 3x do combine together to get negative 5x. That's how we factor a quadratic using the area model. Remember, if I was going to switch this general form to a factored form, remember all I would have to do if I was looking at a rule is I could say equal to y. Okay, thanks.